Okay, we are at question 39 for this video clip. This is a diagram showing a very simple model of a water heater. So a water heater, as the word suggests, heats up water. After the button is being pushed in, water starts to become hot. So let me study the diagram for a while. There's a button here and there's an unknown part Z. You press it, then it seems that this part Z will start to come in contact and close up the circuit. Alright, since there's a circuit, the tank will start to become hot. Suggest a property in order for it to be Z. So it's quite straightforward. Of course, it must allow electricity to flow through. It must be an electrical conductor of electricity. Okay, remember I've mentioned this in class before. Do not talk about it is a good conductor. Do not even use this word. Okay, electricity is only conductor or insulator. There's no such thing as good or bad conductor. Alright, so if you have used the word good, please mark it as wrong. Explain why it becomes hot after the button is pushed in. Okay, so 2 marks again, our exciting 2 marks question, but now we know that we are not as scared because there's a way to follow. So let's look at evidence 1. Okay, what happens when you start pushing in? When you start pushing in, Z will come into direct contact, right? So the action, the contact part has to be there. From the picture I can see that when you press it, there will be a direct contact. Now what is the result of having this direct contact? Your first result, with that direct contact, you form a closed circuit. A very powerful science word to use again. Okay, now we go on to evidence number 2. Evidence number 2 is built from the result previously. So what happens with a closed circuit? Electricity can flow, right? You can't exactly see it, but you see it when it's closed, so-called. Alright, so it's still an evidence. It's like electricity can flow to maybe not to because we can leave this to the final result. When you have electricity flowing, what happens? I see a heating plate. The heating plate will be you can say switched on, or it can be activated, it can be powered on. Okay, then that kind of already explain how the water is heated up already. Alright, so quite a simple 2 mark question. I think I've proven enough time that 2 marks questions are actually quite easy to earn, right? If you structure your evidence 1, your results, your evidence 2, your results 2 carefully, you shouldn't have a problem getting the 2 marks. Okay, now the next question is Adrian commented that the temperature can be increased if the light bulb is removed. Wow, so let's see. Now you remove the light bulb, the temperature can be increased. Okay, I understand there will be a group of you who thinks that when the light bulb is removed, it will create an open circuit, right? I think some of you are thinking it this way. You remove the light bulb, it creates an open circuit. It's like a fused light bulb, it creates an open circuit. Now over here, the sentence, if you read carefully, they are actually very sure that it can be increased 100%, and you are supposed to explain why it happens. So the idea of open circuit will not work here. Alright, we are going to assume that once we take off that light bulb, we close up the wires, so it is still a closed circuit. Alright, our job is basically to explain how come then it can still increase the temperature without the electricity. Alright, now this one actually not an easy question, I admit, because Reason is if you didn't think carefully, you wouldn't know that this question is actually about energy conversion. Interesting, huh? So what happens is when I think of light bulb, I think of light energy. Now we know that by the law of energy, conservation of energy, no energy is destroyed because they are all converted from one form to another, right? Now if you think of it this way, with removing the light bulb, a lot of energy cannot be converted into light energy anymore, right? So what else can be converted into? They have no choice, but they have to still be converted to some other forms, right? So if they cannot be converted to light energy, then they have to be converted into maybe electrical energy. And with more electrical energy, what happens? This electrical energy will be converted back into heat energy because of the heating plate. Alright, so that's the big idea behind it. If I put it in words, evidence will be, since there's no light bulb, because the question already says there's no light bulb, right? When you have no light bulbs, you have got a result. When you have no light bulb, what happens? More of the electrical energy can be converted, because now all the electrical energy are no longer converted to light energy. Okay, now it can be converted into other forms. More electrical energy can be converted to heat energy. Alright, it's actually quite a straightforward question. It's just that I understand that there can be a lot of confusion when it happens. Alright, because we didn't think that energy conversion will come in here, right? Or we thought it was just a simple electricity chapter. Okay? Alright, so with that I end for question 39. Watch the next clip for question 40.